No, I don't mind if you eat or drink, but you gotta ask permission. So, okay. No, I said I don't mind. We just have to ask permission.
I'm not gonna drink.
Oh, okay. 3. But then it's gonna be all melted. It's an icy.
Okay. I didn't throw it away because I didn't have time. Not because I was
This guy, stop listening already. A quadratic polynomial. Are you joking? Okay, what is a quadratic polynomial? Ax squared plus bx plus c, right? This is like last chapter. I should take this problem out. Yay. Okay, next year I'm crossing this problem out. This is like the last chapter. This is baby food. Okay, the leading coefficient is -2, so that's -2. And a constant term of 6, which is 6. And no linear term, that means don't have this term. So it's -2x squared plus 6. Find the zeros. Okay, what's another name for zeros? X-intercept. So you set y equal to 0 and you solve it. 2x squared equals 6, x squared equals 3, x equals plus or minus √3. And anyway, that problem's just way too easy. Take that out for next year. Number 4. Say what? Okay, we got a cubic polynomial now. So ax cubed plus bx squared plus cx plus d. The leading coefficient is 2. Woo! The coefficient of the linear term is -5. This is the linear term. Or was that the confusing part? You didn't know what a linear term is? Constant term, linear term, quadratic term, cubic term? Now it says P of 0 equals 7 and P of 2 equals 21. What do you think I'm going to do with that information? Yeah, plug it in. So if I plug in 0 for x, you get d, and it says that's equal to 7. Oh, just figured out d is 7. Yeah. P of 2 is 21, so if I plug in 2, so that's going to be 16 plus 4b minus 10 plus 7. That equals 21, and then now you can figure out what b is. So 4b is equal to, that's going to be 8. b equals 2. Did I do that correctly?
Yes.
Of course, I'm the teacher. So b is equal to 2. Now you answer the question. Compute p of 3, so just plug in 3 or do synthetic division. Which one did you guys do? Just plug in the 3? Yeah, when it's a cubic, you plug in the number, and it's not that bad, but then when you get higher powers and bigger numbers, right? Can you guys take it from there? Or you want me to plug in the 3? I don't know what you guys. Number 7, 8, 9, 10, and 11. Is this April 1st or something? What? Okay, if you don't know what to do, just do long division. You want me to do long division?
No.
What do you want me to do? I see it on the board. Or are you thinking, Mr. Park, is there a way I can do that with synthetic division?
Yes.
Yes, there is, but you got to know what you're doing. How many people did it with synthetic division? And it came out? Who said what we're doing? We're doing number 7. Okay, so what do you want? Why is it on the board? Okay, if you're on the quiz on Wednesday, you don't know what to do, just do long division, because long division works every single time, right? But is there a way to do synthetic division? Because Mr. Park, I noticed that x squared minus 3x plus 2, isn't that the same thing as x plus 1 times x plus 2? So can I do synthetic division by... Yep. It is minus. I keep telling you in the afternoon when the glare is coming in, just turn your head to the side or something and then you can see it. So can I do synthetic division with 1 and then 2 and then get the problem? Yes, if you know what you're doing. Mr. Park, I don't know what I'm doing. Okay, here we go. So write the coefficients down. 3, -2, -5, -8, 7. So which one you want to do first, the 1 or the 2?
2.
Wrong, 1. No, it doesn't matter. 3, 1, 1, -4, -4, -12, -12, -5. Did I do that correctly?
Of course, you're the teacher.
Okay, now you do synthetic division with 2 now. So woo! So you got 3. Do it on what's left. Yeah, 3, 6, 7, 14, 10, 28. Oh, so Mr. Parker, get this. That stands for 3x squared plus 7x plus 10. That's the quotient. Okay, that's easy. But what about the remainder, Mr. Parker? Look at the answer. The answer says 8x minus 13. How the heck do you get that? That's why you gotta know what you're doing. Anybody? You're done?
You keep going, and then you put it at the end, so you get 8x minus 3. Like, you use the 8s on the remainder, and you keep going with synthetic equation until...
What do you mean you keep going?
You keep going, so you get...
Just leave it on my desk. Not you. But. What do you mean keep going? Keep doing another synthetic division?
No, on the line, like...
Right here,
yeah,
on this line.
8 times 2 is 16, and then...
8 times 2
Never
is
mind.
16.
Never mind.
Oh, you keep on going. 8 times 2 is 16, and then you get 11.
Oh, never mind.
No, EA. 9, yet. No. Anybody? Why?
Just go -5 over x minus 1 plus 8 over x minus 2.
Okay, say that again.
-5 over x minus 1
Okay, so this remainder, so negative 5 over,
x minus 1 plus 8 over x minus 2.
like that.
Then
Why is that though? Is that what you did too? Why are you raising your hand
I
then?
was gonna do it. I was just gonna like make 8 negative 8 and then add them together.
So did this work? Did this work? Okay, so if you have this and this, what's the least common denominator? X minus 1 times x minus 2. So on the top you're going to get negative 5 times x minus 2 plus 8 times x minus 1. So you get negative 5x plus 8x is 3x. Minus 10 minus 8 is minus 18. Is that correct? No?
Isn't that plus 10 minus?
What? Minus 10 minus 8 is minus 18.
Plus negative 5 times.
What?
Minus 2.
What?
Like times x minus 2.
What about x minus 2?
And then you multiply by negative 5. Negative 5 times negative 2.
What?
Negative 5 times negative 2.
What? Anyway, this is wrong, okay? This is not right. So nobody got it. I thought somebody would get it. Usually every year there's like 2 or 3 people in every class that figure it out. Park, Takaki. He didn't even do his homework. Oh. Look, he just picked up his papers like 10 minutes ago and he got it. So what is it? So what is it?
Isn't it the negative 5 over 1 minus or x minus 1 needs to be divided again by x minus 2? And then you do the same thing with the 8, except you don't divide again. And then if you combine it...
Okay, this is what Takaki's saying, I think, but he's just mumbling. So you take this remainder, because when you divide by x minus 1, isn't it negative 5 over x minus 1? But then when you do synthetic division again, now you're dividing by x minus 2, so this has to get divided by x minus 2 as well. You know what I'm saying? And then you get plus 8 over x minus 2. Is that what you're saying? Yeah, and that's correct. Because, see, when you're doing synthetic division, you can't just do it, you got to know what you're doing. You know what I'm talking about? When you do synthetic division, you're dividing by x minus the number in the box. So that's why you get negative 5 over x minus 1. But then, when you do it again, you're dividing by x minus 2 now. So you have to divide that by x minus 2 as well. See, because now watch. If you make the least common denominator of x minus 1 times x minus 2, what are you going to get? You're going to get negative 5 plus 8 over x minus 1. So that comes out to 8x minus 5 minus 8 minus 13. And is that the answer? Yes! So that's what you're doing. So yes, you can, but you got to know what you're doing. You guys just want me to tell you a recipe, yeah? Park, why are you saying yes? You're off Team Korea. You never were on anyway. Here, you guys want, okay, okay, I broke down already. You want a recipe? Here's the recipe. So you make the you make the denominator x minus 1 times, well, you can just see right here. So this number gets, so that number just goes there, but then this plus this number gets multiplied by x minus that. Then. How you like that for a recipe? Anyway, so what's the lesson? Some of you are going, what? I don't get it. So what's the lesson? If you don't know, no, do long division, because long division always works. Number 8. No! X minus 1, okay, put question mark. X plus 1. Are these factors of x to the 100 minus 4x to the 99 plus 3? Now remember last week I asked you if you understood the remainder theorem? This problem will tell me if you understand the remainder theorem or not. How do you determine if x minus 1 is a factor? If I divide that into that and there's 0 remainder, right?
Yeah.
So one way you can do it is you could do long division. I don't think we're going to do that, right? Another way is you could do synthetic division. How many people did synthetic division? Oh, you did! So you went like this. 1, negative 4, 98 power, 97, 96, 95, 94, 93, 92, 91, 97, 96, 85, 84, 83, 82, You guys really did that? And then, oh, 3. We'll put dot, dot, dot. This means you don't understand the remainder theorem. Yes, you can do that, but why not? What's equivalent to doing synthetic division with 1? What does the remainder theorem say? If you do synthetic division with 1, that's the same thing as plugging 1 into the polynomial. So if I plug in 1, you get 1 minus 4 plus 3. What is that? 0. That's the remainder. So therefore it is a factor. Remember I told you last week, you have to decide, is it easier to do synthetic division or is it easier to plug in the number? In this case, isn't it easier to plug in the number? No, I like writing plenty zeros. Are you guys crazy? You guys wrote 90-something zeros. Sasaki looking guilty back there. You wrote 90-something zeros. What? Oh, you did. You plugged in 1.
Yeah.
Who else plugged in 1? The rest of you wrote 90-something zeros then. Well, oh, you wrote dot, 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 you said.
Yeah.
Okay, what about this? How do you test if this is a factor? Write another one with 90-something zeros. No, just plug in -1. So you get 1, plug in -1 there, plus 4, plus 3 is equal to 8. Is that equal to 0? Are you my mother?
No.
No. So this one, yes, that's a factor. No, you're not my mother. Now do we understand the remainder theorem? If you do synthetic division with a number, the remainder is the same thing as plugging it into the polynomial. Okay, and are we really doing the rest? Please. Okay, number 9. When a just look, if you just read what it says and just write it down, this problem's easy. If a polynomial is divided by 2x plus 1, let me ask you this. When you divide a polynomial by a divisor, what do you get? You get the quotient plus the remainder over the divisor, right? Okay, let's fill in these boxes. Do we know what the quotient is? Minus x plus 4. The remainder is 3, and what's the divisor? 2x plus 1. It says find p. What can I do to find p? Just multiply both sides by 2x plus 1. So the answer is going to be p equals 2x plus 1 times x squared minus x plus 4. And what happens when you multiply this by 2x plus 1? You just get 3. So all you have to do is just multiply these two things and add 3. Can you guys take it from there? You guys know how to do long multiplication. I told you guys last time. Okay, 10 and 11 are the same problem except different. Which one? I will do 1. Which one you want to do? 11. Okay. Wait a minute. No. Are you? No. Oh. I am exasperated, number 10. I actually told you one of the roots. No, I want to do it. I want to do it. No, I don't really know, but I'm doing it. Okay, look. If I tell you 3 is a root of the equation, the remainder better come out to 0, right? So let's see. So 2, 6, 1, 3, -1, -3, 0. So that means you can factor it as x minus 3, and then the other factor is you look at the different coefficients here, 2x plus x minus 1 equals 0. Now once you get it down to a quadratic here, you either factor it or use the quadratic formula. Does that factor? Yeah, so you factor it some more. What is that? 2x, x, 1 and 1, plus and minus. So once you have it all factored, what are your three answers? 3, 1/2, and negative 1. If I tell you one of the roots, that means if you do synthetic division with it, the remainder better be 0, right? And if it didn't come out 0, you did something wrong. Now number 11, you have to do it 2 times. So let's write down the 1, negative 2, 1. Okay, did you guys forget to put the 0? That's my question. Did you forget to put the 0? No, because I'm just copying it off the board now, Mr. Park. Okay, which one you want to do first, negative 1 or 2?
Me too.
Why do you pick the wrong one every time? Okay, no, let's do the long way. Let's do the wrong. No, it's not long. 1, 2, 0, 0, 1, 2, 2, 4, 0. See, it better be 0. But then there's another root of negative 1. So now you do synthetic division on what's left. So 1, negative 1, negative 1, 1, 2, negative 2, 0. So what does this all mean, Mr. Park? Well, that means x minus 2 is a factor. X minus negative 1 is a factor. And the other factor comes from the depressed coefficients here. X squared minus x plus 2. Can that be factored? No, so you use quadratic formula. So 2, negative 1, and then just use the quadratic formula here. Woo! You guys can do that. Okay, I'll put use quadratic formula. Or just look at the answers on the bottom like some other people do. Is that what you guys do sometimes? You get stuck, so just write the answers on the bottom. You guys are hilarious. Okay, so tonight's homework, look how easy. We're graphing tonight. Now, Mr. Takeyasu's students, typically, they are good at graphing polynomials because Mr. Takeyasu taught them the dance of the polynomials, right? Right? Did you guys learn this last year? The dance of the polynomials?
Yeah, except that's not it.
What about Mr. Rubash? Are you guys, he probably didn't do the dance, but you guys are good at graphing polynomials? Who's Mr. Rubash's class? So, okay, well, I don't care because I'm going to teach you like you don't know anything, right? Okay, let's start graphing. Y equals, let's start off really simple. Super simple. Okay, first of all, end behavior, right? It's in your notes. Don't pick. Why are you guys taking notes when I made notes for you? Oh, so you're doing homework while I'm lecturing then?
Oh, no.
Oh, I can't wait till you get Mrs. Goto next year. Snap your neck quick you do that. Alright. Okay, so whenever you graph polynomials, the first thing you do is plot the x-intercepts and the y-intercept, right? Now, if the thing is in factored form, x-intercepts are easy, right? What are they? Negative 2, 1, and 3. Y-intercept, you simply plug in 0 for x, right? Hopefully we can do that in our heads quickly. What's 2 times negative 1 times negative 3?
6.
It's 6. So should I go 1, 2, 3, 4, 5, 6, or just go like this? Change the scaling, 6. You want to do 1, 2, 3, 4, 5, 6? So what happens if it's like 65? Then change the scaling. Each hash mark is 6. You guys like the... Okay, now end behavior. Whenever you have an odd degree polynomial, it's either like this or like this, right? Does that sound familiar? Odd degree. It's like, this is what, okay, if I were to multiply it all out, what's the highest power of x ever be?
3.
3, so it's odd degree. So the end behavior, you guys know what end behavior means? It means on the ends. It's either like this or like this. How do you tell?
Negative.
If the leading coefficient is positive, it looks like this. If the leading coefficient is negative, then it looks like that. And you know, if you cannot remember, just think of y equal x. What does y equal x look like? Doesn't it look like that? What does y equal negative x look like? Doesn't it look like that? Because that's odd degree, right? X to the first power. If you have an even degree polynomial, then it's either like that or like that. If the leading coefficient is positive, it's like that. If the leading coefficient is negative, it's like that. Just think of y equal x squared, right? Y equal x squared, doesn't it look like that? Y equal negative x squared looks like that. Okay, so which one is this? Leading coefficient positive, odd degree. What's the end behavior?
Like this.
Like that. Okay, so all you gotta do, this is all I want tonight. I want quick sketches. So all I want to see is this. Okay, that's a little too pointy, -1. You guys know polynomials don't come to sharp points, right? They're all nice, smooth curves like that. True or false? The maximum value. Okay, what kind of point is this called?
Vertex.
No, only a parabola has a vertex.
Maximum.
Yeah, I know it. What kind of max? What did we learn last year? This is called a mountain. Yes, this is a maximum point, but what kind of maximum point? Is it the highest point on the entire graph?
No.
If this were the highest point on the
Local.
entire graph, we'd call that an absolute maximum. But this is not the highest point on the whole graph because this thing keeps on going up forever. So we call this a local maximum. Does that sound familiar? Because if you compare it to points nearby, it's the highest point, but it's not the highest point on the entire graph. How come some people are going, yeah, yeah, and some people are going, no, no, no. Okay, what about this point over here? That's a local minimum because this is not the lowest point on the whole graph, just compared to points nearby, because the graph goes on forever over there. Okay, now true or false? This local maximum point occurs halfway between the two x-intercepts. True or false?
True. True.
It's false. That only happens when you have a parabola. Once you hit third degree or higher, it's not going to be halfway in between. It's somewhere near halfway, but it's not halfway in between. Okay? What about here?
False.
True or false? The local minimum occurs halfway between the two x-intercepts. Yeah, I already told you it's false, right? Do we know exactly how low to go? No, we don't. So tonight, I just want to see a sketch, okay? Quick sketch. We don't know, next year when you take calculus, then you're going to figure out exactly where that local minimum and maximum is without a calculator. You guys know you can do it with a calculator, right? Okay, take out your calculator. How do we calculate local max and local minimum points? Okay, so first of all, y1 equals this. Type that in your calculator. Let's do this minimum one over here. So the first thing you do is type it in. Graph it on your screen. Probably, why don't we start it with a zoom standard? Zoom standard. No, zoom standard. Press the zoom button. Zoom standard. Zoom 6. Zoom. That's so barbaric. Just go zoom 6. Why do you want to scroll down to the 6? Just press zoom 6. Okay, now, how do you calculate this minimum point? So you calculate, select calculate. Now look at your menu. You added cal ahead. Where's your calculator?
In another classroom.
You should have pretended. Look, it's so obvious. You're looking over somebody's shoulder. Too late already. I already know. Why do you want to do it now? Okay, well, I forgot what I said already. Okay, calculate, select minimum. What does your calculator say? Left bound. Move the cursor somewhere to the left of that minimum point using the left and right arrows. This is for TI people. Press enter. Then it says right bound, so move the cursor somewhere to the right of that minimum point. Press enter. Then it says guess. Are we going to guess?
Yeah.
No, remember the last time we don't guess. You just press enter again, and then your calculator will give you the coordinates of this minimum point correct to 5 decimal places. So tell me what it is.
221.19196.
No, you give 3 decimal places.
And
120.
yeah.
Is he correct? How come I was hearing different numbers? Marcy? I was hearing different numbers from you. And then what about the y coordinate?
Negative 4.061.
Did everybody get that? Okay, now what about the prism people? Can you guys get the minimum? Al got it. Come on, if Al can get it, come on. You gotta get it on your screen. You gotta change the window then.
But wouldn't you see it like? How do you do it?
You have to get this graph on your screen first of all.
I got it.
Okay, now how do you calculate the minimum?
Yeah, I got it.
Yeah, well, what did you do? Tell everybody else.
Oh, G solve.
G-solve and press the minimum button. Duh. So actually, Prism is actually easier than TI. Just press the G-solve button, press the minimum button, boom. Okay, but you know what? What if your graph, let me just ask you this. What if your graph had like several minimums? You know what your calculator is going to do? It's going to give you that one. Yeah, then you press it again, then it gives you that one. Then you press it again, it gives you that one. Whereas if you had a TI, you got to calculate the minimum here, left bound, right bound, guess, boom. Then you got to do it again, left bound, right bound, guess, boom. Left bound, right bound, guess, boom. So Prism is a little bit easier. Okay, that's basic. Okay, now are you ready to kick it up a notch? Okay, y equal x plus 2, x minus 1, x minus 3. Okay, let's put a square on one of these. Which one?
The one.
Second.
The one.
Okay, are the x-intercepts still -2, 1, and 3?
No.
Who said
Yes,
no?
yes.
What do you room? No. Look, it's on factor 4. Is the y-intercept still 6?
No.
No. Because now what happens when you plug in 0? You get 2 times 1 times -3. It's -6 now. Okay, what is the degree of this polynomial? 4. Leading coefficient positive, so the end behavior is like this. So watch. What's the part? How come the thing went bounce off that x-intercept? Okay, you guys learned from last year, yeah? When you have an even power on the factor, it bounces off. Does that sound familiar? When you have a 1 power, it just goes straight through the x-intercept. And like I said, we don't know how far down to go. All I ask for is a sketch, so I'm just looking for something like that. You can use your calculator to calculate this minimum point if you want to. Okay, let's kick it up a notch. Y equal x plus 2, x minus 1, x minus... Okay, which one you'll put a 2 power on?
3.
2, and then what about a 3rd power?
Second.
Okay, here we go. Are the x-intercepts still -2, 1, and 3?
Yes.
Okay. Y-intercept?
No.
That's not even a question. Y-intercept. Plug in 0 for x. So you get, some of you need to do this, yeah? 2 times -1 times 9. If you have to, because if you get the wrong y-intercept, your graph is going to be all screwed up. Okay, so what is that? -18. Make 18 hash marks, Morrissey? Or you just make 1, -18. Okay, what is the degree of this polynomial? 6. Leading coefficient positive, end behavior like this then. So, okay, I'll tell you what I'm thinking when I draw this graph. Ooh, -2 came from this factor, has an odd power of 1, so it's going to go straight through. Okay, now, I'm coming up to this x-intercept, has an odd power of 3, so it's going to go through, but it flattens out like that. And then now I'm coming down to this x-intercept, has an even power, so it's going to bounce off. Oh. Did we learn this last year? Odd power goes through, even power bounce off. But you have to know the difference between 1 and 3. See, if you have 1 power, it goes straight through. But if you have a 3 power, it flattens out like that. Why? Just like y equal x cubed. Why does it flatten out?
Because when you cube a decimal gets smaller.
Yeah, when you raise fractions to powers, it gets closer to 0, so that's why it flattens out. And then if you had a 5th power, the thing would flatten out even more. Ooh, it would be like that. You know what I'm talking about? And then what about bouncing off? If you have a 2nd power, it just bounces off like a parabola. But if you have 4th power, it bounces off, but then it flattens out. Again, because when you raise fractions to powers, it gets smaller, closer to 0. Now in this class, you just have to know the difference between 1, 2, and 3 power. You don't have to worry about 4. Okay, so now you think you got it? So, on the quiz, next quiz, which is on Wednesday, I'm going to give you the graph, you write the equation. So here, this will test to see if you understand what's going on. Okay, 1, 2, 3, 4. 1, 2, 3, 4. So let's say, whoa, whoa. Okay, write the equation of this polynomial function. But I'm probably going to graph it on my calculator. You're going to see it. Okay, so how should I start this? X-intercepts. Okay, what are the x-intercepts? You guys not answering the question. X plus 3. So negative 3, negative 1, 2, and 4. How many points do I get for that, Mr. Park? Nothing. A dog could do that. I want to see the powers. Now, look at negative 3 right here. Whoops. Yeah, second power. How do I know it's not 4?
Because you said we don't know
Okay, right. You only have to know 1, 2, and 3. I'm not trying to trick you. I'm trying to make it easy for you. Okay, what about the power on negative 1? Square. No, it goes straight through. 1 is the power. What about that 2? 3. Yeah, because the thing flattens out. So that's 3. And then 4 bounds off. How do I know it's not 4? Okay, I'm just checking. Fox, that's the answer. No, minus 2 or 3 still yet. What? Because how do you know what the number is in the front? And anyway, look at the end behavior. It's like this. If the end behavior is like this, shouldn't the leading coefficient be negative? Okay, so minus there. Well, how do you know it's minus 1? How do you know it's not like minus 2 or minus 1/3 or something? Yeah, so there is a number in the front. We don't know what it is. How do I figure it out? Well, you said it. Plug in the y-intercept. This is the point 0, here, 24. If I plug in 0 for x and 24 for y, you can figure out what a is, right? So 24 is equal to a times 9 times 1 times negative 8 times 16. Therefore, a equals 24 over, should I multiply out those numbers? No, you leave it. 9 times negative 8 times 16. You know why? Because then you can go like this. 8 goes into 24 3 times, but 3 goes into 9 3 times. Every year, there's always people, they multiply out all the whole bottom, and then they start canceling. You start canceling first. So what is a? Negative 1/48. So your final answer is going to be y equal negative 1 over 48 x plus 3 squared times x plus 1 times x minus 2 cubed times x minus 4 squared. Woo! Isn't that pretty easy? Polynomials are pretty easy. Until we get to the hard part. Yeah. No, it's not hard. Okay, tonight's homework easy. We're done. Did you guys learn the rational roots theorem last year, yeah? Because you guys know, when you do it's not up here. When you do synthetic division, it's guessing and checking it. So you know the number you put in the box. Did you guys learn like what numbers to put in the box last year? Yeah. What? Does this sound familiar? P over Q. Do you remember what that means? No. Okay, we're done.